Have you ever considered, how did the Earth form? In what way will it be destroyed? The story of the Earth started as a massive spiral galaxy, the Milky Way. 100,000 light years from the galaxy, there's a swirling dust cloud and hot gas. This simulation attempts to present a scene spanning 50 million years. And this isn't the long river of the universe, just a fleeting moment. In that period, millions of stars die in violent explosions. These explosions are called supernovae, shown here in the form of a flash. They will make up the material of the planet, spreading the universe. Elements such as carbon, silicon, and iron. The energy released by a supernova explosion, enough to cause nearby star clouds to collapse. Bodies. There is a special planet, primitive Earth. He is growing steadily. However, his fate hung in the balance at the time, full of unknowns and variables. Once upon a time, we believed that the formation of planets, it follows a predictable pattern. From our solar system, the nearly circular orbits of the planetary neighbors is the best proof. And not only that, between gaseous exoplanets and rocky inner planets, there is also a clear division. Gaseous exoplanets include the majestic Jupiter, mysterious and beautiful Saturn, deep and cold Uranus, and icy blue Neptune. And rocky inner planets have hot Mercury, soft Venus, the Earth of life, and the resilient Mars. This clear division, it begins to appear shortly after the star ignites. The young sun generates powerful hot winds, like an invisible force, push the lighter hydrogen towards the outside of the disk. Gaseous exoplanets, by absorbing the gases ejected by the sun, they grow very quickly. It keeps growing. And this is dusty. An inner region devoid of gas and ice became the birthplace of Earth-like rocky worlds. The discovery of a new generation of planetary telescopes. Shocking. Gaseous planet the size of Neptune. They usually cruise around the inner area. Shattered our traditional understanding of the distribution of planets. It was also discovered that Jupiter, sized giant planet, we're orbiting our stars at very close distances. Hot stellar winds is relentlessly stripping the gas from them. In addition to that, it still exists a class of large, rocky planets. Scientists call it a super-Earth. These mysterious planets, how on earth did he overcome all these obstacles to get there? Why are on inner planets, but still so small? This series of questions become a puzzle that puzzles the astronomy community. In fact, what we know about the formation of the solar system. Fortunately, some of the larger ones survived the fall. Scientists, by measuring changes in molecules called isotopes, in-depth analysis of these precious planetary fragments, the study found that these fragments, it seems to come from the inner and outer solar systems. Two different groups of asteroids formed. This shows that between these two regions, there must be some mysterious force. It creates an impenetrable barrier, so that objects cannot mix freely. If this huge dividing line, it was young Jupiter, then his growth rate must have been amazing at that time. He will be like a barrier, could always be in the most influential chapter, plays a central role. Its role and significance are far-reaching and significant. Scientists use supercomputers. By treating dust, the star gradually forms its unique orbit in the outer regions, presented in blue. As time goes by, Jupiter continues to grow. Subsequently, it began to orbit the Sun in a spiral. Scientists, this significant change in Jupiter during this process, it's called a big turn. The name comes from the state of a sailboat when sailing against the wind. In the course of Jupiter's great turn, he passed through the diffuse cloud of debris in the universe. The material that has not been swallowed by Jupiter was thrown out of the solar system. As Jupiter approached, pulled Jupiter's orbit back. And the Earth at that time, in the universe, it's just the embryonic form of a future planet. With the departure of Jupiter, Earth, and dozens of other stars in the process of evolution, obtained, the opportunity for free competition, collision becomes inevitable. Ultimately, in this intense process of cosmic evolution, there are only a few possible worlds left, which includes what we know today, the major planets, and at least one other planet. The existence of this planet, in the history of human exploration, after a very famous milestone, it was determined after a series of scientific deductions. July 16, 1969, Apollo 11 successfully launched America's heavy launch vehicle, the Saturn V, during its 13th launch, driving through alien terrain, collecting lunar rock samples. When the astronauts returned to Earth, the whole world cheered for it. They are the first and so far, the only ones to leave Earth and successfully landed on Earth, humans from another world. Few expected it at the time. They brought back rock samples from the moon. Will raise questions about the moon and the Earth. A series of major scientific discoveries. Returning to the NASA laboratory, scientists have conducted in-depth research. Discover moon rocks share many similarities with Earth rocks. It is particularly worth noting that they share the same isotopic form of oxygen. This feature, it is regarded as a unique symbol of the celestial bodies in the solar system, as iconic as blood type. From the characteristics of the lunar surface, the moon is littered with massive ancient craters. It's surrounded by concentric rings. At NASA's Lunar Reconnaissance Orbiter, in recent images of the Eastern Sea, can be clearly observed. These geomorphic features, these concentric rings, suggest that during the evolution of the moon, there was a giant impactor, hidden, hot liquid surface in a tumbling state, and it creates ripples upward. Astronauts near this dew point discovered scattered relatively light rocks. These rocks, most likely when heavier materials sank into the magma, exposed to the ground by being squeezed. In addition, they also discovered some that were later nicknamed as become a rock. These rocks are composed of potassium, rare earth elements, and phosphorus. These rocks are called anorthosites. It's the product of a molten surface. As for why the moon formed a lava ocean, and how it is related to the Earth, the most widely accepted theory, currently, take us back to Earth about 4.50 billion years ago. There may have been volcanic activity on the surface of the Earth at that time, and has a thin toxic atmosphere. The Earth at that time, in the later stages of planet formation, waiting, the major test of the subsequent birth and evolution of life. In the distant universe, there is a planet. It's about half the size of a planet. It's gradually approaching the planet, and that planet is Theria. In the evolution of the universe in which we live, could have been related to the planet we are on, unique worlds that have coexisted. However, the fate of the universe is not like this. When Theia and our Earth, in the event of a violent collision, his own journey came to an abrupt end. Let's try to imagine, as the ultimate threat looms in the sky, from the perspective of the Earth, what an amazing sight that would be. The impact of Theia, like a giant storm in the universe, deeply shocked the core of the Earth. Its atmosphere. As time goes by, these fragments gathered into a huge cloud, gradually coalesced into one, a belt of molten rubble that glows fiercely. While most of this debris in Earth's orbit, like dense raindrops, falling back to the surface of the Earth. But the amazing thing is, in just a century, the remaining fragments cleverly came together, formed a wonderful and magnificent celestial body. That is the Moon, Earth's faithful companion. After the specific subimpact event, our Earth began a process of rapid rotation. The tilt angle of its axis of rotation is higher than before, slightly changed. The Moon's orbit at that time compared to its present position, closer to Earth, so the vast and bright surface of the Moon, almost the entire sky, with the Moon under attractive forces, gradually slide towards a farther orbit. It has a certain resistance effect on the Earth. Under the influence of this resistance, the rotation of the Earth is gradually slowing down. At the same time, the inclination of its axis of rotation also gradually stabilized. The Moon is more than just an icy moon. In the history of our planet, the cataclysm that nearly wiped out the entire planet, the faithful witness and memory bearer of. However, from that distant past to the present day, the Moon has become a reassuring part of our lives, and a very popular place. It symbolizes a stable source of strength, bringing us endless peace and harmony. Meanwhile, a unique brilliance shines on the Earth. It's a picture of incredible erosion and traces of geological events on its surface, the retention impact. To gain a deeper understanding of that history, scientists conducted a significant study. Researcher, according to the Moon, the size and number of craters, through sophisticated scientific computer models, the impact on the Earth at that time, simulated. The research results show that, during those turbulent years, the Earth has experienced at least 4 times huge impact event. The energy of each impact, enough to reshape the surface of the Earth, fundamentally altered the course of Earth's history. During the impact, these massive celestial bodies are overwhelming, impacting fire on the Earth's crust containing radioactive uranium and potassium. Powerful impact, causing these elements to be violently torn from the Earth and ejected into the vastness of space. In the field of geology, this complex and spectacular process is called impact erosion. The tremendous energy of the impact, a fiery crust formed on the Earth's surface. When the intensity of the impact activity finally tapers off, this layer of shell has a faster heat dissipation speed, capable of cooling faster. And in the gap between impacts, those are relatively small, but a large number of impact events, carrying a large amount of water vapor into the crater. Partial impact is also linked to minerals deep in the Earth's surface. Tightly bound water can be released. In this series of events that followed, under continuous influence, 500 million years after the Moon was born, the Earth gradually evolved into a water world. The vast continuously in low Earth orbit. Its attractive force raises the tide, a powerful impact on the rocky volcanic coast. Earth's atmosphere, it's a mixture of hydrogen, nitrogen, and carbon dioxide, and water vapor is mixed in Earth, already capable of accomplishing its ultimate feat. All the necessary conditions for life. But there was a problem. The Earth's water resources are gradually decreasing. The young sun, it wasn't as bright as it is today, but it is prone to intense flares. These flares hit the ground, the upper atmosphere of the sphere. When solar particles hit water molecules, will explode. The lightweight hydrogen will float into space. The relatively heavy oxygen sinks to the Earth's surface and combine with rocks. Now we know for sure what are the consequences of this process. From observations of the spacecraft, Mars in the distant past, it had abundant water resources. Its surface is carved by the winding paths of ancient rivers, and it is littered with sediments from lakes and ocean beds. And the current Mars has become a lifeless planet. Its atmosphere is a thin layer of carbon dioxide. With the help of special sensors on board the orbiter, recorded Martian water resources, continuous loss due to solar radiation. Scientists have landed on Earth's sister planet, Venus. The same process was observed. The atmosphere of Venus today, filled with all kinds of toxic chemicals. Thick sulfur clouds are also part of it. The atmosphere on the surface of Venus, very high levels of carbon dioxide. Carbon dioxide as a potent greenhouse gas, capable of absorbing the heat of solar radiation, makes Venus look like a fiery cauldron. The surface temperature of Venus is almost 500 degrees Celsius, the warmest of the planets in the solar system. Active volcanoes scattered across its surface. This further exacerbates this harsh environment, erupting sulfur and carbon dioxide. Then the Earth. How did you avoid falling into such a tragic situation? First, Earth has Venus and Mars, the missing protective barrier. A magnetic field that can deflect the strongest radiation waves from the Sun towards the Earth. This magnetic field is by heat exchange between the Earth's core and crust produced. This is just Earth's first line of defense. A billion years ago, another line of defense on the Earth's surface has begun to form. The long-standing theory holds that heat and chemical reactions, proteins and nucleic acids were bred. These two key chemicals that make up life. Recent views point out that hot springs were widely distributed on the land of the early Earth and other volcanic landforms. However, no one knows for sure how life began. Where did they get their first roots? What we do know is that life did happen, and with a crucial breakthrough, the ability to convert sunlight into energy, to multiply widely. Photosynthesis. This is the process by which plant life depends. First appearance among simple bacteria more than 3 billion years ago. Scientists, using one of the world's most powerful supercomputers, trying to unravel the chemical mysteries of photosynthesis. In the early stages of photosynthesis, the first task is to capture sunlight. Sunlight passes through the transparent membrane and reaches the center of the bacteria. Here you can see a cluster of spherical pod structures. Each spherical pod, all are equipped with special sensors for harvesting solar energy. When photons hit, it activates the chlorophyll ring. This energy is passed along in turn through the protein family, electrons and protons, transferring energy through a series of chemical reactions. and the energy for these reactions comes from the sun. Now, cells need to convert this energy into actual movement. The energy stored in protons prompts objects to move. They flow into the water spaces inside the cells, tearing the towering molecular structure. When these protons flow in, the charge it carries, it turns the protein around like a crank. This rotation triggers a chemical reaction. For all life on Earth, are of vital significance. Two molecules combine. It forms a third component called ATP. Children are usually shown in blue in related displays. ATP is in every cell but has ever-lived. Universal energy currency. It's like a bio-battery, capable of storing energy captured from the sun and reintegrated into a stable form. For cells to break down food to drive movement, provides energy for reproduction and life-sustaining activities. The microbes are able to thrive because of ATP. As bacteria evolve, they give rise to plants, more advanced stages of photosynthesis. It creates a byproduct, oxygen. Newly generated free oxygen, more than the land and sea can absorb, in the atmosphere. It binds to hydrogen, prevent it from escaping into space, simultaneously generate new water molecules. This process, gradually slowing the trend of the Earth's oceans drying up, but it doesn't stop it completely. According to a recent study, Earth, currently, it still lost as much as 25% of its original water reserves. On the surface of the Earth, water, life, the sun, geologic activity all working together. Together, they power an extraordinary planetary engine. Climate change, partly driven by the day and night cycle, and the change of seasons, caused by uneven solar heating. These factors plays a regulatory role in the Earth's global temperature, pushing warm equatorial winds towards the poles, blowing cold polar air towards the equator, tides and currents, mixing cold water from the deep sea with warm water from the surface, solar energy and carbon dioxide, destruction, greenhouse gases on Venus, trapped in the atmosphere together by water vapor. The key factor in controlling carbon dioxide emissions is unique to life on Earth. The ocean is teeming with white crocodiles. Tiny phytoplankton can absorb those who were swept into the ocean by the waves, or being sucked from the depths by ocean currents. Carbon dioxide ingestion from the ocean. Then they will deliver the carbon atoms upstream in the food chain. Phytoplankton become food for zooplankton, such as Radiolaria, creatures that date back 500 million years. It was life in Earth's oceans at that time. Boom period. From the perspective of classification hierarchy, race apart, any of various tiny arthropods resembling crustaceans. They're also the largest source of protein in the ocean. Octopus larvae are members of a large ecological community. It's actually smaller than a human fingertip. Oil-free animals are preyed on by small fish, and the small fish will become food for larger creatures. Every step in the food chain, carbon that was originally part of a diffusing gas in the air, are being passed on to larger and larger animals. Usually, the larger the organism, the greater the mass of carbon it contains. From whales to microscopic phytoplankton, marine life, they are all important components of the global ecosystem. The system is capable of extracting carbon dioxide from the atmosphere, and then gradually release it back into the atmosphere. The key to the carbon cycle, the ability of the Earth to store carbon over the long term. A NASA satellite, chlorophyll monitoring is ongoing. Chlorophyll is a kind of, it can be used to monitor plant growth, missing chemical agent. As the seasons change, plants absorb large amounts of carbon dioxide and release the oxygen we breathe. On land, when plants and animals die and decay occurs, carbon goes underground. Earth itself is also involved in this process. When it rains, bare rock absorbs carbon dioxide, and erosion will carry it into the ocean. If it is rich in carbon deposits, become part of the marine food chain. As time goes by, carbon-rich sediments could be converted to oil, or form lime, stone and other rocks. Once these deposits are exposed to the surface, or affected by Earth's volcanic activity, the carbon goes back into the environment. Every year, volcanoes release carbon dioxide into the ocean and atmosphere, more than 100 million tons. The carbon cycle contributes to the formation of a habitable environment on Earth. It is of great significance. Its effectiveness depends on the phenomenon of life on Earth. Earth today, with vast oceans and complex atmospheres, and a vast solid land, sunny, warm and pleasant, and we've created a world where people live in abundance, an ecologically balanced habitat. When we study the Earth in depth, the operating mechanism of this complex system, all the precision feats required for its operation, marvel at the synergies, the legacy of supernova explosions, Jupiter's attractive forces, an accidental celestial collision, and the birth of the Moon. These factors together contribute to the formation of water resources and the birth of life. The more capable we are reconstructing the Earth's past evolution, the more you will find, and it has wonderful properties. We are gradually realizing there are countless other star systems in the universe. So, it's a question. Is the Earth just a multitude full of life, a member of the habitable world? We'll say, this is a unique existence by an extraordinary coincidence. Our Earth is like a paradise. But is it the only paradise in the universe?